Hello, hello. I see you. I'll be right there. Bear with me for a second. Sorry for the lateness. I'll be right there. I am looking for something in particular. Yes. Okay. I'll be right there. I see you, but actually, I don't see you. I'm lying. Hold on one second. I'm sorry. Uh, okay. Okay. Just about there. So sorry. I'll explain everything in a minute. Okay. Kidding, not kidding. I will say hello. Sorry, I actually can't see you guys. Hold on one second. Okay, I see people now. Hello, Vincent. Nice. Hello, Jocelyn. Hello, Vanita. Hello, Vicky. Hello, Melanie. Hello, Jean. Oh, wait, I'm looking at the chat now. I'm sure you have. Okay. Hello, Vanita. Hello, Vincent. Good morning, Jean. Good morning, Vicky. Okay, here is the deal. Oh, hello, Vicky. Yes, hello, Vicky twice. Okay. Uh, Please listen. Okay, this is going to be this class that we're about to have is very important. It's meant to reduce stress, not increase it. I have a sense that right now, perhaps there may be a little stress. Bear with me, but listen closely to this entire class, please. I mean, a lot of what I'm going to say is not expected. I mean, you can all hear me, right? Like, wait, people are coming. Hold on. Just to let me know if you can hear me and you're like this is going to be a weird but very important class. So just like raise your electronic hand if you're with me. Oh, maybe you're not. Wait. Thank you, Vicky. Thank you, Annie. Thank you, Jocelyn. Thank you, Vanita. Okay. Thank you, Melanie. Thank you. Oh, that's nice. Okay. All right. So listen. There's a lot of things. Wait. Thank you. Well, more people coming in. Just bear with me for a second. I know you're seeing number right now that maybe if you're looking at a number, you just got something back that you don't like, I'm with you. Just hang on. Just don't get upset yet or whatever at yourself or at me. Just hang tight for a second. If I'm assuming you're seeing a number right now, some of you, maybe you're even leafing through and seeing comments. You'll have plenty of time to do that. I get that some of you might not like the number you're looking at. Please pay attention to me. Like, don't freak out about the number or start getting too obsessed about the document just yet. Let's listen to, well, all right, let me be super clear. Am I correct that anybody who's with me this morning now has their long-awaited midterm exam back? I mean, is that correct that you see it in Google Classroom? Okay, thank you, Vicky. Thank you, Josh. Or Jocelyn, are you asking a quick? Thank you, Benita. And Jocelyn, is that a raised hand or you? Oh, okay, great. All right, so I'm assuming you have your numbers back. I know you've been waiting for them for like too long, and I know that many of you may not like the number. Again, please stay with me. Don't obsess about the number right now or the document. You'll have time to do that later. But listen to me closely for this like whole class, okay? And I'm gonna say a bunch of things about the end of the year, about grades, all that. And then I'm also gonna say before I get any further, I'm gonna say some similar things in the other section. Oh, hello, excellent, good to see you. Okay, I'm gonna say, or maybe that was okay. Oh, okay. I'm going to say a lot about wrapping up the semester and about grades and all that. And then in the other section, I'm going to repeat the same things, but much faster. And I'm going to spend more time on the physics content that you'll want to know for the final exam and stuff like that. So I'm going to post both videos. I highly recommend you listen to both of them and maybe very carefully so that we can all do as well as possible in this last week. Okay. Oh, that is correct. Okay. Thank you for the direct chat. I see. So, wait, there's more people coming. All right. but I'm going to give a bunch of kind of unexpected instructions here. So again, even if you fade out today, like this would be possibly among the more important recordings that you'll want to watch over and over again, like end the semester as well as possible. And again, also the other section, that happens in an hour. Okay, I'm kind of stalling because I want to make sure everybody's here. Hello, Gabriel. Um, Kind of, but I'm not going to stall that much longer. So again, here's what I hear. I have a number of things to say. No problem, no problem, direct chat people. Good morning, good morning. Okay, well, I'm late with getting back your exams, but you have them now. You again, I'm talking to everybody, even if you just walked in. You see your midterm exam and you see your score. I know that the scores are possibly a little bit disappointing or scary. They always are, but I know it's a little scary. They always are, and there's always room to rectify. And the grades, final grades, are always better for anybody who's still with me than whatever that number is on your midterm. Okay. But I will admit it's a little scarier to get them like right now in the last week. And some of the numbers were, in fact, a little scarier than you might have wanted. So here is the story. First of all, I continue to believe that you are a wonderful class. Like really, I think you. Yeah, yeah, okay. Some of you may have done way worse than you expected. And I'm seeing in the direct chat. I understand that. I'm here to address that, like in a big way, not just emotionally, but in an academic way. And by the way, if you did fine, if you think you did fine, then that's great. But still listen to. Then you could calm down. But still listen to me as to how we're going to end the semester because it's not in a totally normal way. Okay, so everybody needs to hear this no matter what. But if you're at all upset or worried, you definitely want to listen to me. First of all, I'm still with you. Okay, I still think you are a great class. For real, all of you, anybody who's sitting in the room right now, like I'm looking at all the names. I know who you are. I know you've been here all semester. I know you've been trying. I know physics is hard and harder than we expect, or hard in ways that are different from whatever. It's hard. I still want everybody to do really well. I want everybody to learn the physics as much as possible. I want people's grades to be as high as possible, like without, cheating or anything like that, without you cheating or me cheating for you, right? And there's still a strong chance and time for that to be true, despite what the number may look like to you right now. Okay? I mean, first of all, the whole grading system accounts for a lot more than just that number. And if you want to talk to me privately about that, again, I will. But much more to the point. Okay, here is what I came to realize, like looking at all those exams and finishing them much later than I wanted to. I think perhaps this semester, where I've been sick, as you know, I've been sort of trying to act like I'm not sick or trying to but I think it had more of an impact on me and my teaching and on you than I was hoping or than I realized. Like, I think the semester may have been harder for all of us in some subtle ways that I wasn't even acknowledging to myself. Maybe you were, maybe you weren't. And it certainly didn't help that you had to wait this long for midterm scores to be back. So here is what we are going to do in part to like embrace and acknowledge that I want to take a lot of responsibility for this. So I'm just changing the view of the screen. Okay. This is not a criticism. This is compassion for all of us, including myself. What we're going to do, despite what it looks like in Google Classroom right now, whatever the final exam is, the old final exam that's posted in Google Classroom, like when I get a chance, I'm going to get rid of that. You have to take a final exam. It will be due, a week from Wednesday, whatever we said in Google Classroom. Okay. But your final exam, please listen closely, is going to consist of two problems that you do, just like your midterm did. Wait, before I go, now that I'm getting to the meat of this, please raise your electronic hand if you are with me and you're ready to hear how we're doing the final exam in this class. Great, great, great. Thank you. Okay. So you're going to have two problems on your final exam. One of them, you're going to take the problem that you did worse on in your midterm and you're going to redo it. Same exact problem. I'm not even reprinting it or whatever. You are going to redo that problem as well as you can. Again, you can talk to other people. You can watch old videos. You could take whatever feedback I put in the example. Obviously, my handwriting sometimes is hard. Oh, and I will post I will post my solution set to that exam. I mean, it's not perfect. It's just like what I use to grade. So it's still, I still expect you to show all work and all that kind of stuff. And some places I do, and some places I don't. But I will post, and you can remind me by the end of this period or whatever. I will post the solutions that I use to grade the exam. Okay. And you have my feedback now on the exam. So one of the two, and I don't, even if you rocked it, you're going to take, which is great if you did, you're going to take whichever problem you did worse on, and you're going to redo that problem as one of your two final exam problems. Okay. Because I want us to learn and da 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 da. Like, because for all the obvious reasons. But I also think that will be sort of easier and more educational, then whatever. I'm not going to justify it right now. I can personally if anyone wants to ask. But with help from other people, with looking at my feedback in the thing, with looking at my solution set, you're going to redo one of your two problems, your worst problem, as one of your problems for your final exam. Okay. And one big advice I'm going to give right now, if I run out of time, is like show tons of work, show all the steps. And many of you were very good at attempting to show steps and label the steps. That was very helpful. That was good. Keep doing that. But let me emphasize even further, since this has been tough and it takes a while to get used to my methods. And so I'm basically giving you a second chance here. What you want to do in your exam is make it like, think of it as a presentation. You want to put most of your effort, especially if you're going to do the same problem again now that you've already thought through hard and now you've gotten corrections on it. Put a lot of your effort into presenting it as clearly and thoroughly. Wait. Yeah. Wait. Sorry. I'm going to stop right now because there's at least one question in the chat that says what's probably on a lot of people's minds. That I'm not going to read the name, obviously, but there's one question in the chat that says, even if I failed my exam, which they mean the number is a failing number, even if I failed my exam, if I pass my final, can I still pass the class? Yes. That's what I'm here to tell everybody. We are not done with this class. I am not done rooting for you. I am not done supporting you. I'm not done believing in you. I'm dead serious. And you are not done having a strong chance to do okay in this class. I know the midterm scores were disappointing. And again, frankly, they always are. They're always a little scary. It's the first of four exams that you take in 2 semesters of physics, and you have to get used to physics, and you have to get used to me. They're always a little scary, and the grades are always, but since you're learning it now and you may be rattled, I am telling you directly, even if the number on your exam looks like a failing number, like it's in the 60s, the 50s, or whatever, yes, if you're listening to me right now, if you're still in the room, that means you've been doing homework, you've been trying. Yes, you can still pass this class, like for real. And in many of your cases, you could do better than passing. Okay. Again, I can reassure you, the answer is yes. That's why I'm like yelling. I'm not trying to get you more stressed. I am trying to ease your mind and tell you we are not done yet. And partly why we're going to change the final exam so it's kind of like a second chance at the midterm is so that not only can you show yourself that you know it better or that you get what I'm looking for better now, but also so that you can feel like it was worth your time, that you actually learned something. Okay. So one of my things I want to say to you is this is going all both ways. Like I took a long time to do them. I can't afford to take that long again next week. I can't afford it with your lives to do that. So one thing you really want to do is make those exams really, really clear and easy for me to follow. I will admit that a lot of them are a lot harder to follow than I kind of expected. Like make sure the pages are in order, write really big, leave lots of space, be really clear, like make a rough draft, make a final draft, you know, like treat me like I'm an infirm old person who remembers his physics, but whose brain is getting foggy. Because frankly, maybe that's happening more than I realized. Okay, so you definitely can still pass, more than pass, but you got to redo one of those problems, whichever one you did worse. Wait, sorry. Yeah. And I'm going to answer and I'm going to tell you what the second question is in a minute. Yes, I'm looking at the chat. But the first thing you want to know is you're going to redo one of your problems, the one you did worse on. You're going to redo that as one of your final exam problems, okay? And by the way, if I forget, I'm saying all this also loudly so If I forget to post anything that I'm promising, you can text me and remind me. Like, I'm going to post solutions to that exam to help you. Okay. I forget. Okay. So make your solution, your presentation, and this, and, some of you did, but some of you didn't. Just you're trying to teach me physics at this point. Like, you're trying to make the physics, you get my point. Just make it really, really presentable and neat and clear. Your goal is for me to have an easy, enjoyable time looking at it and a fast time looking at it. Okay, I think I'm dragging that. So that's one of the two problems you're going to do. Again, if there's anything unclear, you rewatch this video, and I'm going to say in the other video. But now, as somebody is asking in the direct chat, what's the other question that's going to be on the exam? Also, so that you're not wasting your time and we can feel like we're getting ahead rather than behind all this. The other problem on your final exam. Wait, I'm going to stop. Are you still listening? Like, you're still with me, guys? I'm about to say what the other problem is. You'll see it that it's in the post. Great. Thank you. Okay. The other problem is essentially going to be the first homework assignment for Physics 204, which I've now posted. I mean, I know you haven't taken 204 yet, but this is the point. The first assignment in Physics 204 is right where we left always, where we leave off in 203. Well, like, the last material we do in 203 is about work and energy, right? That's what we were doing last week and stuff like that. I'm going to finish talking about that today, a bit in your section and more in the other section. Where we're going to end the material today is where we pick up in 204. So the very first assignment, so this is also going to give you an advantage in 204, okay? The very first assignment for Physics 204 is now posted in the exam section of your Google Classroom. And if you're still listening to right now, I'll tell you the very last part of that sheet, the last part where you ask something hard, the very last, that will not be on your exam. We'll do that in 204. You can cross that out like right now or whatever. But the main thing is like the first four parts where it asks about like force and acceleration. And it asks about, especially when the main point is, if you're looking at it, it's about a mass on a spring, which I'm going to talk about today. But your main goal in that thing is to find out how fast a certain mass is going after it's moved a certain way along a spring. So you have to use like kinetic energy and work. That's our last topic of the semester, right? I'm going to finish that topic today. So I am telling you, the two problems on your final exam, despite whatever old exams may be in Google Classroom right now, and I will remove them when I get a chance. The two problems of your final exam will be redo whichever problem you did worse on in the midterm, and then do a spring problem, which would have been like, it would have been part of your final exam anyway. It's like not okay, but do a spring problem literally in the fashion of our first homework assignment, which is like a review assignment until the last part. You're going to do a spring problem that is posted now in your Google Classroom that will allow you to feel more ahead when you start 204 next semester. You get the point. Those will be the two problems on your final exam. I'll repeat that if I need to in a second or whatever. But let me also make clear to all of you, and again, I'm sorry to be yelling. I just want to be clear about this. Also, I think I promised this last week, but let me repeat it and confirm it. Whichever exam you do better on, your midterm or your final, I'm going to count more. Whichever exam than the other one. I mean, I'm going to count them both. I have to. But I will give more weight to whichever exam you do better on. So I'm going to just quickly summarize again and then make sure you understand. And I'm going to say some other things. But so what in fact, wait, let me see if, well, wait, no, okay. I'm just thinking, do I have to post it? Yeah, I mean, I will try to make this all clear in Google Classroom, but summary, your final exam, which is due midnight of next Wednesday, right? I mean, it's not due, it's due Wednesday the 18th. It will consist of two problems. A redo of whatever you did worse on in your midterm and the spring problem that is now posted in the exam section. It's just called homework 1B or something right now, but that homework 1B thing on a spring will be the other problem on your exam. And I'm going to, whatever time I have left, I'm going to talk about it, or the concepts anyway, today. in this lecture and in the other lecture section. So that will be your final exam. It will count more than your other one if you do better on it. It'll count less if you do worse on it. What else? And okay, is that clear so far? I'm going to stop for a second. Is that clear? Thank you, Hudson. Okay, thank you. Is Hudson the only one? I mean, thank you, Hudson. I totally. Oh, and thank you, direct chat. Okay. Could I get some more? Okay, thank you, Gabriel. I actually really want to make sure this is clear. Um, I mean, I hope it's also in a way good news, but whether it's good or news or not, I want to be clear. I mean, and then yet, well, is any okay? Oh, wait. Yes, wait. Correct, Annie. If you're talking about what I think you're talking, if Annie is referring to the very last bit on, oh, in fact, let me screen share. Hold on a second. I'm going to screen share to make sure that we're super clear here. Hold on one second. But I'm Annie. I think the answer is correct. Yes. Hold on. Yeah, right. She's right. Oh my God, excuse me. Hold on. Okay, this thing that is on the board right now, you see, it's just a copy of like your first homework assignment for next semester. This is what your other problem will be um, on your exam. As Annie just clarified, this last bit, number 9, that's hugely important for physics 204. Like, I'm not like you would told that's where we're going to hit the ground running in 204, but you will not, that is not on your final exam. You can cross this bit right now. Let me see if I can even do this right on the screen. You are not doing that on your final exam. I mean, she is correct. Uh, well, that's okay. Um, Also, let me, before I forget, I'm not saying this problem's a joke, although it is a lot easier if you don't have to do part 9. And the main thing, let me see if I could still, can I still zoom up and down? Oh, uh well, the main thing is like the first 4 questions, the first page of it is the main thing that you're going to be responsible on your exam. I can't scroll for a second. But let me also remind you, like I'm going to try to talk about this and everything, but please remember, uh, I have playlists and playlists and playlists of Physics 204 for like so many semesters since COVID. And all the first classes in all of the playlists from every semester for Physics 204 are like all about this sheet. So I'm like encouraging you. Just like take the time to like play any and all of those videos and watch me walk through the whole homework thing. It's all there, the material. I am again emphasizing that what you want to do, the one thing I'm really looking for, the one thing that I think was, I wish I caught earlier in the semester for all of you, but like over explain when you're writing an exam. Don't under explain, over clarify, over explain, break down all the concepts, etc. Like that is what I'm looking you to do. But you can get all the concepts from all the past videos of this, and certainly you can work with one another. Let me also say again, even though like I'm yelling and I'm intense, wherever there's benefit of the doubt, I'm going to give it to you. Any of you who's on the borderline of any issue, any micro issue in an exam or any macro issue with your grade, I will always, especially those of you who are still with me right now, believe me, the benefit of the doubt will go to you, but you got to give me something to work with, if you know what I'm saying. Like there's I think you understand what I'm saying. Wait, I see things in the chat, so hold on. I'll stop for a second. Hold on. I don't know why. Wait, I might have to stop this something. It might be the screen share that's screwing me up. Hold on. I'm looking at the chat. Okay. Wait. I'm glad about the chat. Also, sorry, I'm gonna have to get the tissue in a second. No, to Vincent, that's the direct chat. The crossed out bit, it's like not even extra credit. It literally won't be on your exam. Like I'm not even looking for it. There's tons of extra credit you'll get on your grade from like all your homeworks and all that kind of stuff. I'm not. I'm a little worried about. I want to get. I don't want to take as long with these exams as I did last time. It doesn't even exist. Yeah, what Vincent said. That part that I just crossed out, the reason it's there, and if I get a chance, I'll try to literally eliminate it from Google Classroom and clarify all this. But the reason it's there is like that will be important in Physics 204. Like it's not, but it just won't be important for you now on your final. Like it just doesn't exist. There's no extra credit. Is so let me pause again. Am I being clear so far? Do you get what I'm saying about like all of this? Thank you, direct chat person. Okay. Okay. Fair enough, Andy. Okay. Thank you. All right. And again, if I, get cut off, or whatever, I think you've been a wonderful class. I think you're trying hard. I think physics is hard. I think there's things that have been harder than I realized. So I'm trying as best as I can right now to embrace all that and incorporate it into both your learning and my grading, if that makes okay. The goal is for us to feel like we spent that this was worth our time. Oh, wait. Well, I don't, well, as far as direct chat, yeah, I mean, so, but the bet that now we are a little bit under time pressure is also kind of why I'm yelling. The best thing I could say about your exams, I mean, is the feedback that I put in it, even though my handwriting is bad and everything. I did try to be as extensive as I could I mean, I didn't just take off numbers. I tried to explain things, but I don't know. And I will post the solutions, but there just isn't time for me to literally walk through the whole thing. I will also say, I'm sure you could find old videos of mine on it, but to be totally well, yeah, I'm looking at the direct chat. I mean, so just the most honest thing I could say is that the most help I can give you with that exam that you just took or just got back is whatever I wrote in it and whatever solutions I post, you can remind me to post them, or I'll try to do that in a second. Um, and there is a time squeeze. I can't really do much better than that. But again, that's why I'm saying to everybody, whatever is imperfect on my side or on your side, I'm trying to be as aware of that as possible. I want you all to do as well as possible. Anywhere I can make it, I can use your numbers and your input to turn it into the best possible output. I will. So, but it's like a matching fund contribution kind of thing, if you know what I'm talking about. Like anything you give me, like in terms of your final exam, like I'll like double it and add 32, if you know what I mean. Like that's a metaphor. But just the more you give me, the more I can work with it and turn it into education and good grades. And that's my interest. But wait, that's a good question, Melanie, to everybody. Um, it is the exact same question. Yes. Will it be the exact same numbers? That I can't promise. I have to think about that. It might be, but it might not be the same numbers, but it will be the same question. So if you understand, if you watch a bunch of my old videos, or you listen to the rest of this period, or you listen to the video of the other period where I'll spend more time on it, I do think you'll know how to do it. It will be the same questions. It might not be the same numbers though. If that makes sense. Wait, just tell me if I answered or. Okay, well, I think I answered. Okay. Um, I'm gonna pause again. The other reason I'm being so intense right now, and I'll calm down in a second, but wait, sorry. Um, I will calm down in a second. I'm being intense because it's an intense time of year and it's getting harder for me too, and it's getting hard for all of us. But I please, like the message, I just want to reinforce again, the message is I believe in you. Like I think you guys are working hard. I think you deserve to do well. But you can't cheat and I can't cheat and won't cheat for you. So we're doing everything we can to legitimately show as good physics as we can to make the numbers as legitimately high as they can be. And and I want to start next semester with like less stress or whatever. So hence this whole idea. Okay. I'm looking couple other wait, oh, I'm going to pause one more time. Like we will get to physics. I'm going to get back to physics in a couple of minutes because we still have time. I'm going to pause for a second. One more. Oh, stop. Well, wait. I see the direction. So one of previous topics will be on the final exam. I mean, yeah. Well, I'm saying the final exam will consist of two problems. one you've already done. So yes, it's a previous topic. If that's what you're saying, yeah, you half of your final exam, you're going to redo something you've already done again, so that you could feel better about it and I could feel better about it and all that. So yes, that would be a previous topic. Then the other topic on your final exam will be essentially work and energy, which was the topic we were ending on anyway. So that's not a previous topic. That's our last. So yeah, half your exam will be old and half your exam will be the most recent material. Does that it? And that's on usually everything on the final exam is just new stuff. But I don't want to do that to you right now because I feel like if you just got rattled by the old stuff and you I want anyway, it doesn't matter what my reason is, but oh okay, okay. Are you sure you get I'm looking at the direct chat. If I'm gonna pause for a second. I want you do. Okay, 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 okay. Uh raise your hand if you think you get what I'm saying, folks. Like honestly, or yeah, okay, thank you, Vanita. Okay, thank you, Vincent. Uh, thank you, Gabriel. Thank you, Gene. Okay, see, there's more people. Thank you. Okay, I mean, put if you even if you're not sure, well, I'm going to assume you do. If there's got an issue, like we're here today to do this. If you've got, and again, even if I don't get to talking about a ton of physics right now, I will in the other section. Then you just play the tape. So, is there any? I'm going to pause for one more. Even if you're thinking like, I don't know what to ask, but I'm confused, or so you could put that in the direct chat. If you're like, I don't know what's confusing me, but I don't feel clear. Like you could put that in the right. And you can put it any time because I'm going to say a couple more little logistical things. Excuse me. Um, excuse me. I may have to run and get a tissue in a second. The other thing is the other reason I'm like yelling so much right now or that I'm so intense is we're not going to meet on Wednesday. This is going to be it for a variety of reasons, some of which have nothing, just for a variety of reasons. And I didn't plan on that, but that's the way it is. So I'm trying to wrap this all up today. And I want to wrap up on a nice, like positive note that you deserve. I also want to remind you before like we could still stay in touch and you can still text me stuff like that. And I'm very much looking forward to seeing you guys again in 204. And I'm very much looking forward to supporting your future, with letters or whatever else. Like, don't be a stranger, but for a little while. And I'm very much hoping you have a great holiday. But we're not going to see each other again for a while after today. What you're going to do Wednesday, this Wednesday, what are you going to do? Well, you're going to use the time to gather yourselves and prepare and sit there and watch old videos, like use an hour and 50 minutes to watch an old video to help you with the final. Also, please use the time to fill out a teacher evaluation, a faculty evaluation, which a lot of you have not done. I'm not telling you what to say. I will never see it. But I am telling you, you get 20 points that you might want on your grade, like that helps your grade. A lot of you still haven't filled them out. I'm not going to take the time to stop class now, but we're not going to meet on Wednesday. So please, if you have not filled out a faculty evaluation, even though like you might be so upset right now, like maybe I just need the data. I will never know what you said, but we need the data to improve as teachers and improve our hiring and promotion practices and all that stuff. We need the data. So please, if you haven't done a teacher evaluation, use the time Wednesday morning that we won't be meeting to do that. And remember, when you submit, there's a portal in Google Classroom. You just submit a screenshot that you did it, one for each section, one for lecture, one for recitation, and you get 20 points for doing that. Oh, also, there's a game turn every night for 5 points. Today is worth 15 points just to make sure that you're here and that you're hearing all this. If you choose tonight's game turn, it's worth 3 times as much as the normal game. I'm just trying to give you as many points as I can to, okay, to like end this semester. You get my point, but like do the game turn for tonight. Just say like I was there. I get the approach to the final exam. You'll get 15 points instead of 5. Do this the faculty evaluation. You'll get 20 points for doing that. If you are an e-permit student, first of all, thank you for joining us. Hope to see you again. I really appreciate you've been here. If you are an e-permit student, my understanding is that you can't actually fill out a John Jay faculty evaluation, which is ridiculous, but or I don't know how you do because you don't have a John Jay email, blah, blah, blah. So if you're an e-permit student in the portal for faculty evaluation, just write, I'm an e-permit student. I cannot do this. And you'll get the 20 points for doing that. Just acknowledge that the opportunity was there and that you hear me. Okay. So if you're an e-permit student, just write that in the portal and you'll get the 20 points. Okay. Uh, okay. So we're not meeting Wednesday. You're going to take the time to try to go over your old exam, to try to look at a new video, to try to gather yourself and to do the faculty evaluation. Is that clear? Can you raise your hand if that's clear? That we're not, that this is our last meeting. Thank you, Keith. Thank you, Vin. Thank you, Miriam. Awesome. Okay. Thank you, Vanita. Okay. Okay. Uh, okay. Again, if I'm yelling, I am yelling. I apologize. It's just it's intensity. It is not anger. Uh um okay. What I'm gonna do now, it's 11:30. We have 35 minutes. First of all, I'm gonna run and get a tissue. I'm gonna walk away for a second. I'm gonna pause the recording for a second. And then I'm gonna try to talk about the physics for the next 35 minutes that will help you with the other problem. Okay. And I'm gonna try to talk about it. I'll try to be sort of as big picture as I can, and then you, whatever. I'll just try my best. But I'm gonna walk away for a second to get a tissue. So while I walk away, can you guys just take a breath and reset yourselves? First of all, no, the message here is yes, we can still all do well. Yes, I want us all to do well. And yes, I'm taking responsibility or trying to take responsibility for any extent to which right now we don't feel confident. Okay. We're going to do fine. There's still a huge chance to do fine. I'm, I hope you hear that that is the message. Um, and so when I walk away for a minute, just catch your breath, like take a breath, like I will do. And then if something's still unclear or whatever, or you want to talk to each other, I'm going to turn off the recording. If you want to like talk to each other for a second or you something, then when I get back, put it in the chat or whatever. But then barring that, we're just going to go on with physics, like the last physics. So I'm going to pause the recording. I'm going to just walk away for a second, basically to get a tissue. I'll be right back. Uh, okay. First of all, I'm almost a little surprised that that never happened before now, but like, thank you, Annie, and everybody who's agreed. You definitely should form a group chat. Oh my God, yes. And you should for 204 too, but yes, please help each other with the final. Like, good, good for you. Yes. Hold on. Yeah, great. Thank you, Annie. Yeah, no, that'd be real. And it's good, good for you guys. That's a good idea. Uh, Now I also see something in the direct chat that's a little harder for me to answer, but like I know it's on what's on everybody's mind, of course, is if I got this, is it still possible for me to get that? Like if I were you, I would be in the same wondering. So what I'm about to say is not 100% precise. I cannot promise anybody any particular grade. I can promise you that tons of A's are still possible. Like, like I can promise you that my grading system is designed so that A, the highest scores do get A's. B, there could be a lot of A's. Like, so let's make that clear. There's no limit on A's still. And and there's no way like if the highest score in the class was a 40 on everything, like that person would get an A, and then a bunch of people in the 30s would get A's too. Okay, so let's first of all let me start with that. And I probably should have and a lot of the scores on this midterm were like 70s or lower. So to be a little bit more specific now, I mean, the specific question that's in the chat is if I got a 77 on the midterm. I mean, I'm not saying who that was, whatever. Someone's saying if I got a 77, could I still get an A? Okay, I have to be very careful about this. Of course, that's an important question. I am not about to sign a contract in blood and but the basic answer is yes, it is. Okay, like it is with the grading system as it exists. And with doing a lot better on the final, yes. If you got a 77 on the midterm, I mean, and certainly if by A we mean A or A minus, Yes, it's still possible. I mean, it's not guaranteed, and you need to, sweat a bullet or two on the final two. But yes, I don't. Yes, it is. That's the bottom line. Okay, I like um your every single one of you, your final letter grade will be a lot higher than the number on that document. Number one, because your other exam's going to count more if you do better. But number two, because remember, you get a ton of extra points from all this other stuff you've handed in, and your lab average counts as well. And if you have any concerns, again, we'll make a phone call and I'll look at your specific situation. But, but yes, it is possible. I mean, that's all. It's not definite, and it won't come easy. But yes, it's possible. And similarly, those of you who got like a 50 or 60, is it still possible to pass? Yes. Um, well, Well, wait. Oh, okay. Wait. What should we expect? Oh, good. I am here to try to, even though I'm yelling, I want you to feel better. Let me be clear too. I want you all to work at the final exam. Like, I don't want you to give up now. I don't want you to think a grade is automatically going to be gifted to you. And yes, I want you to understand that not everybody's going to get an A. Right? So, okay. But I want as many people to get A's as possible. And one person getting an A does not mean that another person doesn't, or so. Like, I still don't want you to compete with each other. I want you to get on that group chat that you're making and help each other. I know I've said this before, but let me say it again now. Like, the goal after today's class is to, yes, to feel like there's something at stake here, that you're going to have to make it happen in the last week to make it as good as possible. But whatever your goal is, you're going to have to make it happen, but it is still possible. Nobody has slammed the door shut on whatever their goal was entering into this class. I guess that's the most concrete way I can put it. But now, and sorry, I do want to move on, but when should we expect final class results? I think I know what you mean by that. I will say you saw, I mean, it takes me a while. I mean, I'm not fast with this stuff. So whenever the grades are actually due, and I usually know this, and I have looked, whenever the grades are due to John Jay is when your grades are going to be posted. Usually what I do is like a day before they're actually, and I think that is usually, I mean, I try to get all this done before Christmas for obvious reasons, but sometimes I can't. I think grades are usually due like the 28th or something like that. You can look it up if you, I can get back. But basically, what usually happens is the day before grades are actually due to CUNY first, what I usually do is put out an Excel spreadsheet to everybody like a day before with like everything tabulated, including their final exam. And I usually give people like a 20-hour warning of what I'm about to post so they can check and know how and why. And if there's any issue, we can catch it before I post. Usually that's what I do. Like essentially so like 20 hours before they get posted, usually you'll get an Excel spreadsheet that breaks everything down for you. Okay. And I say usually, I mean, I would plan to do that this year. Obviously, things have been a little more challenging this year. But so whenever grades are due, and I just can't, okay, I'll look right now. Hold on a second. And then, but again, whenever physics, I don't finish or say clearly in this period, watch the other recording, and that will make it more clear. Okay, I'm gonna look up right now when grades are due. Okay, okay, yeah, God, it's so terrible. All right, so grades are due, from professors December 27th. So, like in an ideal world, I try to have all this done before Christmas for everybody's sake, including mine. Uh, um, but I might not be able to do that this year. So basically, at worst, you should expect that like December 26th, late at night, you'll get some kind of spreadsheet with the breakdown of your final exam and all that stuff. And you'll have like, a day or like to assimilate the information before it goes official. Um, That's the best thing I can say. Okay. Does that answer? Wait, sir. Wait. So direct chat person, does that sort of answer your question? Well, all right. I hope. But yes, please don't feel bad, people. Please think that you still have a week. Oh, okay, thank you. Good, good, good. Please think that you still have a week ahead of you where you need to do work. So do I. It's never a fun week, the weeks leading. You do need to do stuff so we can land this plane nicely, but there's still absolutely a chance to land the plane nicely. And please remember, I want it to land nicely as much as you do. And I don't want you to compete. I want you to help each other. Um, I'm not just saying I don't want, I'm saying the grading system is designed to reward that. Okay, so I'm going to shift gears now. I know we have 25 minutes. Um, I'm going to try to go big picture here. Oh, sorry. I'm obviously I'm moving to the screen. Hold on. Okay. And everything I'm about to say, I'm being conceptual here, but it's all meant to help you with that the problem, your other problem, the final exam. You have to make the application. You watch other videos too, but that's what's in my mind, and everything I'm about to say is that problem with the spring and everything. Okay. So I'm gonna sort of okay. Okay. First of all, picking up where we were, great, Annie. That's awesome. Seriously. Um, first of all, work, the concept of work in physics is defined, triple equal sign, to be the path integral of force. It's how much a force is exerted throughout some region of space, some one-dimensional path of space. The total accumulated effect of force throughout a displacement is what work is. Now, I'll go back to that in a minute, but that's what it is. Now, who cares? Why do we care? I've never said yet. Here's well here. So why do we care? Okay. Why do we care? In order to find out why we care. In other words, my goal here is to derive a double equal sign for work. Like what work is an integral. But what does it do? What does it give us in physics? Well, let's consider the simplest possible case of a net work of a bunch of whoops, sorry, of a bunch of oh my God, I did it again. Of a bunch of work of network being done on some object. In other words, a bunch of forces acting on an object all at once, and like some in one direction, some in another, and you add them all up and you take into account minus signs, and you ask yourself, okay, in the end of the day, what's the work being done by the net force on an object? Like, what's the impact of it? Well, F net equals MA, right? So the net work done on an object would be MA times the displacement of that object, right? Like F net equals MA is like a big point in this course, right? But but recall Right. But we know for constant A, one of our equations from earlier in the semester, when you don't know anything about time, but you know something about space, when you know something moving throughout a space, which is what we're talking about here, we know that if acceleration is constant, the acceleration of an object is, this is just an equation from the beginning of the year or the semester. You can look it up again. It's the equation we used at the beginning of the semester whenever we didn't know anything about the time and we weren't solving for the time. And that's a situation now when we're talking about work, we're talking about forces acting through a space, not a time. So I've resurrected this equation and I'm going to plug it in, right? I'm just plugging it in. So turning the page. So the net work done on an object apparently equals, I'm just recopying, equals that from the previous page. So I can cross out the x's and I can say the net work done on an object, double equal sign, equals mb squared over 2 minus mv naught squared over 2. Okay, I just did a little bit of algebra, right? But what I'm saying here is if a bunch of work is done on a mass, evidently the impact of that work, like the double equal sign, like the consequence. Let me say morning is if you push or pull a mass through a space, apparently you'll change the value of the mv squared of the mass divided by 2 from some old value of that to some new. Like, look, remember, just like x minus x naught means difference in the value of x, or v minus v naught means difference in the value of v, right? It means change in a variable from some old initial value to some new value, right? Whenever we have blah minus blah naught, we're saying how blah changed from its initial value at time equals 0 to some new value. So here, and I'm not saying we've ever seen this combination of letters before, but evidently, if you push something through a distance or you pull it through a distance, through a displacement, evidently you change the value of the thing's 1/2 mv squared. I.e., if you took the mass, measured the mass of the thing beforehand and took the speed, the instantaneous speed of the thing beforehand, if you squared the speed, multiplied by the mass, and then divided by 2 and wrote that number down, first of all, you'd find that the units, if you work out the units of kilograms times meters per second squared, you'd have kilograms times meters per second squared times meters. Maybe I'm saying that too. I'm considering whether I should write that down or not. But if you look at the units, you would realize that the units you're writing down in are force times displacement units, i.e., joules, right? So what I'm saying is, if you looked at an object, you wrote down its mass, you wrote down its speed at like a certain moment, You squared the speed, you multiplied by the mass, divided by 2. You get some number of joules. If you then push the mass through a space or pull it through a space, and when you get to the end of that space, take the measurements again, take the speed at the end of that space, like the last instantaneous speed of it, square it, multiply it by the mass, divide by 2. You get a new number of joules. What this algebra just says is the difference in the two sets of joules would be exactly the number of joules of work that you did on the mass. Okay? Therefore, this combination of letters of measurements, 1/2 mv squared, becomes important for us to track in physics. You may recognize it from another class, but I'm not assuming you do. I'm saying the reason you recognize 1/2 mv squared from another class, the reason anybody ever cared about it in physics, is because it's the combination of measurements that apparently changes precisely according to how much work you do on an object. Thus, from now on, we give that combination of constants, of measurements, we give that package a name from now on, and we track it carefully from now on. From now on, the kinetic energy of an object is half of its mass times the square of its speed. It's measured in joules. It's the property of that mass that's going to change by exactly the amount of work that you do on the mass. If you do positive work on the mass, you'll give it that amount of 1/2 mv squared. If you're pushing it and it's going that way. If you're doing negative work on it, i.e., you're pulling it while it goes a certain way, or like something's going up while gravity's pulling it down. If you're doing negative work on it, then you're taking away that much energy. Okay. So first of all, what I'm saying from now on, like what work is the amount of force that you apply to an object over a space. What it does, you see the difference, like triple equal sign versus double. What work does, why we care about it, is it changes the 1/2 mv squared of an object, which from now on we're going to call the kinetic energy of an object. Okay, so what work does is it changes kinetic energy. More literally, more, and of course you've heard things like this before, but now I'm showing you like the physics way of thinking about it. What I'm really saying, and I know there's 15 minutes left, like, like what is work? Work is a path integral of force. What is energy though? Like I'm saying it's 1/2 mv squared, but what does it mean? Like what is it, right? I'm saying from now on in English, in English, kinetic energy is sorry, is the ability to do work by virtue of motion. And then what does work do? Work transfers energy. That sounds circular. Like, I'm going to repeat that. If you think it sounds circular, it does. You're with me. I'll break the circle in a moment. But I'm saying, what is energy? The ability to do work. What does work do? It transfers energy. What? I'm saying I'm saying energy is like money. What's the point of money? To perform a transaction. What do you do when you perform a transaction? You transfer money. Is that a big circle? It would be if it weren't for the fact that money comes in different forms or things of monetary value come in different forms, right? I want money, the more money I have, the better I feel or something. Because why? Because I have a greater capacity to spend that money on things of equal value but different form, right? If I have $100, I can go buy Pokemon cards. I spend $100, I get the Pokemon cards. In principle, I still have what's worth $100, but it's in a different form now. So every time I do work, I push or pull something through a distance. What do I do when I push something positively through a distance? I give it energy. Where does the energy come from? It comes from me. When I do work on something, I give up that amount of joules of energy. It gains that amount of joules of energy. What's the point of that? Now it can go do work on something else. When we do work, we change the state. Like, so energy, if I'm moving really fast, if I'm really big and I'm really fast, I have the ability to slam into something else and get it moving faster. What will happen when I do that? I'll move slower, right? So energy is the commodity that we just pass around. What is that commodity do? It gives us the ability to pass it around, to affect other things. Affect them how? Move them. So every time you interact with something and you move it, you give it a greater ability to interact with something else and move something else at the expense of your ability to do that. Okay. That's how, so work is the path integral of force. What it does is it transfers energy. What is energy? The ability to do that. Okay. So first of all, one equation, if you're looking for, is that work equals one half change in one half mv squared. Again, to cut to the chase, the big climactic question on the spring problem, like question 4 or something, when it's asking you to get that speed of the mass at the equilibrium position, it's asking you in effect to calculate how much work was done by that mass to get it there by the spring that's had been released. So what I have 10 minutes left to do is discuss, what does this have to do with springs? Like, why do springs come into this whole discussion? Okay, remember again that work in general is an integral of force relative to with regard to displacement. I'm going to also warn you now, like a big part of the whole discussion about work 2 days ago was like that it's a dot product and there's vectors and there's angles. That's all important ultimately for physics 204. I can sort of tell you right now, don't get all stressed about the angles and the vectors and all of that for this final exam. That's not the part you need to like overly worry about. The part you need to understand is that work is an integral of force with respect to distance. Now, it's that it doesn't need to be an integral in the what we said last week is as long as the displacement's small enough that the force doesn't change, then you don't even have to worry about calculus. It ends up just being force times displacement. However, a lot of times you do have to worry about the calculus. And one such example is the example of a spring. All springs, so this is very important now. This is like a new piece of information, right? What a spring is a system that exerts a position dependent force. I'll write it again on the next page. Okay. We have 7 minutes left. And by the way, I'm gonna spend the 7 minutes trying to explain this slide in English, but I can also tell you I can slow down slightly because as far as direct knowledge or math or equations or anything else you need to know, this is it on what you need to know to do this other problem. Now I'm gonna just like try to put it in English, but what I'm saying is, well, actually, I'll finish writing the math so that you have it. Okay. That's all the math you need right there. So 5 minutes to explain this in English. The point of elastic material, the point of a spring is that a spring has some kind of stiffness to it, some amount of newtons of force that it exerts per meter of length. Like a spring, as you know, like if you have a spring right here, if one end's attached to a wall or a piece of gym equipment, the other end of the spring normally just sits somewhere that we're going to call x equals 0 from now on. Say you put a mass at the edge of a spring, like right while it's just like sitting around happy dappy. So you put a mass at its equilibrium position called x equals 0. If you try to hold the mass out here, like 5 meters from the equilibrium position or 10 meters or whatever, if you try to hold the mass somewhere other than its equilibrium position, the spring exerts a force trying to get the mass back to its equilibrium, right? If you're holding the mass on the positive side, on the right side, the spring will pull to the left. It'll exert a force. And if you're on the other, if you push the spring in and you're on the left side of the equilibrium, the spring will pull out to the right. So wherever the mass is, other than x equals 0, whatever position x the mass is at, the spring will automatically try to yank it back to x equals 0. That's what the negative sign there is in the F. It's always, the spring's always trying to pull it in the opposite direction from wherever it is. It's always trying to pull it to equilibrium. But what's the K times X business saying? It's saying that the spring may have a certain amount of stiffness, K, measured in newtons per meter, but that's a stiffness constant. The interesting thing about a spring, why we use them in gym equipment or in door hinges or wherever we use mattresses, is that if you really think about it, a spring tries harder and harder to restore a mass to equilibrium the farther away from equilibrium the mass is. It's harder to hold a piece of gym equipment like out here than it is to hold it there. And it's not hard at all to hold it where it belongs in equilibrium. So, unlike the force of gravity, unlike the force of mg, which is constant no matter how high above the ground you are, the farther away you are from equilibrium, the harder the spring pulls. It pulls with a force that is directly proportional to displacement, right? F equals negative kx. K is a constant, but it's like the slope of a graph where the dependent variable is F and the independent variable is X. That's what a spring does. So a spring is a perfect example of something that changes its force continuously throughout a certain displacement. That's where the integral and all the calculus discussion of last week comes into play. If you want to know how much work a spring does to bring a mass back from some edge, toward equilibrium, you'd have to integrate the spring force, negative kx, from wherever the mass is to the equilibrium position of zero. And you know from calculus, right? Right. So the variable is x. So I'm doing the integral. I mean, I'm doing it fast, but you only have to do it what? Like once you see this, then it's like always true about springs. So the integral of negative kx dx, well, negative k is a constant. It comes out. And then so you're getting the integral of x dx. What's the int? Well, that's like the antiderivative, right? I mean, I'm saying this quickly, but so you do the power rule backwards. The antiderivative of x is x2 over 2, right? And then because there's a negative sign there, you could get rid of the negative sign by flipping the limits of integration. I'm doing this fast, but just think about it at home. I'm saying the work done by a spring always to get something from a certain position back to zero is 1 fkx squared. And what's the purpose of that? Whatever that work that the spring does will change the mass's kinetic energy from some old value, maybe zero, to some new value, right? That's okay. It's 12:05. That's all you need to know, really, to solve the other problem on your final exam. But again, I'm warning you again. I want you to drag it all out and explain it like I am, like in as much detail as you can. Bring it, like show that you've learned about work for the last few weeks and energy and all that stuff. Watch the video. But that's math wise. That's all you need to know to solve the problem. Just do your best to fix your other problem and extensively explain this one, and that will be your final. And obviously, you can text or email me between now and then, and I'll do my best to be helpful on whatever issue, physics or grades. But that's it. It's 12:05. Um, You really have been a great class. You will have turned out to be a great class. You will do well. I root for you. I believe in you. I'm going to leave. Well, I'm going to turn off the recording and I'm going to post the solutions in the Google Classroom from the other thing in a moment. I'll hang out here for a second. Yes, yes. Okay, hold on. Okay, so I'm stopping the recording.